Hello everybody. Today we're going to talk about JDBC, Java Database Connectivity. In this video we will talk about the history of JDBC, what it is, how it is used, how to install it, pros and cons, and JDBC in action.
Today I will be giving you the history of Java and JDBC. The history of Java. Java was first theorized in 1991 by Sun Microsystems, and then Java was first released in 1995. And within the first 3 weeks of release, Java was downloaded over 220,000 times. And some history of JDBC. In 1997, Sun Microsystems released JDBC as part of the Java Development Kit 1.1. And one of the major updates to JDBC was adding XML support, which was added in JDBC 4.0 along with the Java SE 6 in 2006. Today, 75% of professional developers use Java as their primary language. Java has over 4.5 million developers and is installed on over 2.5 billion devices. Java is the most popular programming language in use. This chart just shows you that in 2010 there was a study of all the programming languages, and as you can tell, Java is right here at the top. C#, JavaScript, Objective-C, C++, and C are right in here. And even though this was in 2010, this still holds true today. And so, since Java is so important, that makes JDBC very important and a very useful tip to connect to databases, since it is the most popular programming language. So people need to know about JDBC.
JDBC, also known as the Java Database Connectivity API, has many uses. It is able to provide a standard interface for accessing databases, usually relational in Java. It is also used whenever you need to connect to a database in Java. Any database can support JDBC with a driver. Some of the databases that support JDBC would also include MySQL, Oracle DB, H2 SQLite, MS SQL, MariaDB, and as you can see, many more. You can connect to a database by creating a connection object, which Jared Shepard will show later in the video. You can also create statement objects to query and update the database. And lastly, it has use to let you view metadata about the database.
Installation of JDBC. To install the tools needed to work with JDBC, you only need to have Java Development Kit installed, since Java Development Kit has JDBC on it. No more installation is needed. To find how to install Java Development Kit, go to the description box below, where you will find a link to their downloads page. Pros and cons of JDBC. Benefits. No installation. Most of the time, JDBC is driver-based, so as long as you have the driver, there will be no need for more installation. Multiple database, one interface. You can open connections to multiple databases in one interface. Creates XML, extractor of data from database automatically, as we saw in history of JDBC. And a pro that might be a con, depends on how you see it, is that there are no real alternatives other than JDBC when working with databases in Java. Cons. Need for a specific driver. There is no a generic driver that will work with all databases. You must have a specific driver for a specific database. Cannot update or insert multiple tables with sequence. Sequence is always random.
I'll be demonstrating how to create a Java application with JDBC to connect to a Microsoft SQL Server database. To get started, we'll need the Java JDK and Maven. The JDK will allow us to compile our programs, while Maven is a dependency manager which allows us to import packages from other vendors. So what this does is there's a central repository full of packages that other people have written, companies, individuals, and we can import them to our programs just using XML versus downloading the library and importing it in our IDE. So we're using this to get a driver that Microsoft provides for JDBC, which allows us to connect to Microsoft SQL Server. Maven may need to be installed depending on your IDE. For me, I use IntelliJ, which has it pre-installed with the IDE itself, but with NetBeans or Eclipse, it may need to be installed. So to get started, we'll visit Microsoft's developer page for JDBC, and it gives us an idea of how to structure our program and what we need to do. So here it shows us the dependencies that we need to import with Maven. It's just a simple XML snippet that you need to copy and paste. And then it gives us some sample code here that we can use later on. To get started, we have to add the Microsoft SQL Server driver to our Maven project. So we'll go ahead and copy and paste this dependency snippet here. And we're going to paste in our pom.xml file. The pom.xml file will tell Maven how exactly to build this project and its dependencies. So this up here will tell it that our main class is com.shepherdjerry.java mssqlexample.main. And we do that twice for different plugins, which are ways we can customize the build process even further. So this, for example, will allow us to run the project directly after building versus executing it through a command line. And here at the bottom is our dependencies, which tells Maven exactly what we need for this project to work. So at this point, in order to exactly compile correctly, we're going to have to add a scope tag. And we're going to tell it to include it during compile time. So now Maven knows that, okay, when we create the jar file, we need to include this dependency here, so it knows how to load it. Next, we'll go ahead and take a look at a sample application using this build here. So we have a main file here with a main function. So we start off by defining a connection string, and all it is showing exactly where we want JDBC to connect to. So we started off by saying it's JDBC URL. We want the SQL Server driver, which we imported previously right here. We have the domain, the port, database name, username, and password. So everything done to connect to the database is done in this single string. After that, we have a try catch block. So we start off by creating a new connection, and we get a connection from the driver manager. So what that there does is it gets a driver based off of the connection URL. So the way it knows which driver to get is based off of that right there. After that, we're going to run a function to create a students table. We're going to create a couple of objects and run a demo, which I'll go into later. And then we drop the students table. So these are just functions and tables I created for the purpose of demonstrating how to connect to all this. So let's just go through the basics here. We have a create students table method, which accepts a connection object, which we created previously up here. And it throws a SQL exception, which will be catched by the catch block over here. So we define our SQL statements in strings. So if I want to create a table, I just write it exactly like I would in SQL. And we get the connection, we create a statement, and we want to execute an update. And then we just pass on that SQL string we created earlier. And that's all it is in order to run any SQL. It'll work fine with anything you can do in standard SQL. There's nothing special about it. And we're going to do the same thing with the drop tables function. So all it does is drop table students. We execute the update just like before, and it works exactly as you would expect. So we have a student table here with a UUID and a name. This right here is similar to a GUID that Dr. Stahl mentioned. It's just Java's implementation of it, so same concept. We created an object called student with the ID and a name here, a getter and a setter. And then we also have a database access object, which is a design pattern to simplify common operations from an object-oriented language to a relational database. So things like inserting, updating, deleting, and loading. So our demo here is going to create a few new students. You'll insert them to the database, print out everybody in the database. It'll change John Doe's name to John A. Doe, update it in the database, print out again, and then delete John Doe. So we have this function here that will just print out the database as it is currently. So let's go behind and see what the SQL actually is here. We have a string just like before, but instead of using the student's name and ID directly, we actually do some wildcards with question marks. So this is one way to do it here by actually putting the variables directly in line, but that's not a secure way to do it. It makes us vulnerable to SQL injection attacks. So we're going to use what's called a prepared statement versus a regular statement. And prepared statements allow us to change these wildcards to the values we actually want. So what we're doing here is we're going to get the connection, and we're going to tell it we want to prepare the statement, this string. Then we're going to tell the prepared statement to set index 1, which is right there, to the ID, and we're going to transform that ID to a string because the database stores strings, not IDs. Then we're going to do the same thing with the name, and then we're going to execute it. So it's a few extra steps, but it allows our application to be secure. And that's the same for the updates, for the delete, and the load is a bit different. We just do a select statement. We have a results object, which is, you can think of it as a bunch of rows, kind of in a list. So we have the same format for the statement as before. We're going to create a statement, and then we're going to execute query rather than a update. We're going to pass that string down, and then we're going to tell it while results set next. So in other words, while there is a next row to work on, we're going to add to the students list a new student, and we just fetch the objects like from the database using that result set. And these are the names of the columns here. We return the students list, and that's all it is. So we'll go ahead and run this and see if it works, which it should. So first thing we do here is we're going to run Maven package, which tells Maven to create the jar file we want. It'll go ahead and compile everything we need. Succeeded. So now we have our jar file. Next, we're going to go ahead and execute it. And look at that, it works perfectly.